All right, this is a light shocker. This is the wave which has the particle way back here and the magnetic region is way out in front. So it's a particle wave duality. We put it through a venturi here, which forced the particle to accelerate right out of the wave and exceed the wave, just like a jet fighter exceeds itself when it breaks the sound barrier. This is breaking the light barrier. And at this point right here, the light particle itself, which was a box of electrons, it was two electrons like this. When it concussed, they separated. Not only did they separate, they actually separated charges from the black from the white. Now this is a single wave coming through the air. The particles way back here. Pulse, 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 pulse. This is the leading edge of this pulse red laser. As it concusses with all the particles in front of it, it has to plow everybody out of the way. They become sort of excited. This becomes the most excited because it's the most concentrated. It's the red laser. Now, let's see what happens. This is a single slit we're going to be looking at. Watch. All right, this is a single slit, and it also is accelerated, this particle, pulling itself out of its own wave, just like a jet fighter exceeding the sound barrier. This is exceeding the light barrier, explodes here, divides into its black and white components, and then comes back in electron showers. And the electron showers come back into what they call interference patterns. Now, this is a single slit, single. They call it a double slit, and one goes this way and one goes that way. That's why they interfere with each other and make this. This is a single slit, and the reason these interference patterns show up, because it looks like a wave, but if you were shooting behind it and looking, it's a spinning particle. That's the particle. And it spins. Sometimes it spins off this way. Sometimes it spins off over this way. And it's all over the place. You see them, they're everywhere. It's not just this one shooter. This one here is the main source. But they're everywhere. So some are going to be way over here. Some are going to be way over here. And they end up doing this. They will always keep a separation between them, the white particles, because they don't want to touch each other. They just get the hell away from me. The black particles, they don't care. They're right about a lot of the stuff, but there's a lot that they're not right about, and I think I could have a lot to shed on this, and I'd like to be heard, because otherwise nobody's seen this before. This is all brand new. Just like I told you, there's a particle coming down here spinning. Just like this, spinning to the right, spinning this way. Now, it spins over, and it goes over this way, and it comes over this way. Some go this way, some go this way, some go this way. The major goes through. If you talk to any machinist that's ever known what a drill bit looks like, that's it. It's drilling through there because it's a spinning particle of light. Red is very long wavelength like this. It spins slowly. Green is down in here. Blue is like way down in here. Blue, we can't really make out the particles. But let me show you the red and green particles. All right, this is the red coming in. No look to it whatsoever until it just before it concusses. Then you get this, the black and white, up spin, down spin, it doesn't matter. They wobble, they shake because they're going through the air spinning. Now, when they hit the venturi over here, they just explode, and the two particles that were locked together, the black and white particle, go right apart. The black goes away, the white explodes. Exactly what they asked for in the muons and electron showers. All right, that was the black ball, and this was the white ball. Coming in, they're neutrinos. When they concuss, they turn into just the black ball doesn't change. The white ball turns into electron showers. The black ball is extremely, extremely attractive to the white to bring it back to it. Other than that, it does absolutely nothing. It doesn't emit anything. It doesn't absorb anything. It doesn't really do anything at all other than gravity. And that's what they also say. Now these are the particles as they spin through the air. The black and the white is attached, and one of those just like that. That's what we would consider an electron. That is extremely invasive to you. Lightning, electricity, static, all are little sparks going through the air, zip, and trying to get into ground. That's what that is. Nobody's ever seen the black. All we've ever seen is the electron. You see this go through the air. A whole batch of these together is lightning. It's static. It's electricity. But nobody's ever seen that before because they didn't put it through a crusher. Let me change that statement. CERN has seen these and had no clue about them. They just say, wow, look at that particle. Let's build something for $5 billion and try to figure out what it is. Well, we could have saved them probably half of that. I think I showed you the red electron, but I probably will again. This is the green ones, and the same thing. As they concuss and they slow down or speed up one way or the other, they display their architecture of that back-to-back bar magnets. Nothing more than just two little bar magnets back-to-back. Nobody knew about the black part. All right? This is a neutral particle at this point because it has two electrons back to back, so it's like a bar magnet back to back. It's got a range that it surrounds around it, magnetic range, just like you take magnets and they're going to push away or pull one in. Now, if it has a full complement of electrons in the nucleus, and that's all nucleuses are, is a big batch of electrons. If it has enough electrons in there, 1840, that's a neutron, and at that point it says, I don't want any more electrons, I'm good. That's what's considered a stable nuclear particle. Right? And protons will have a charge to them that will say, I want another electron to come in. But you'll have so many other particles in the nucleus that says, no, no, you keep them away. Those are called the quantum things. So you'll have like 6 or 7 extra electrons want to get in here because it's still pulling like crazy. The black is a real puller. But the white ones say, no, 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 we're set. Because the white ones will coat this. This is a single photon. When you build a molecule and an atom, the black ones go to the center. And they may violate, or they may work correctly with the Pauli exclusion principle, because it says that's a whole other issue, but that's what they're talking about right now. They're trying to figure out how these dark matter stars and dark matter accumulates, and how does it condense? What happens to it when it condenses? Does it just condense into nothing and all you have is this glowy ball? No. In my mind, it condenses into its... It will go right up against each other. It has no problem with doing that. It won't push back against each other at all. You push the white ones together, forget about it. Boom, they explode like a bomb. And I showed you that, and I'll show you again, because it's very simple. There's the black ones. They just get out of the way. They just say, okay, you guys are crazy. Go ahead, do what you're going to do. And they do. They fight and explode and push and shove and bang and slap and kick and do all kind of things, and these guys just say, all right, do what you're going to do, have a good time, we'll meet you on the other side. And some of these probably come there, but there's got to be a ton of black ones over there just waiting to be adhered back to the white, because the white is now in the shower mode. It's 100% exactly identical to what CERN is asking for. And then of course we have the boson shower, we have the showers, Higgs fields and all this stuff, and these are actually moving Higgs field, and that is a very, very unusual incidence, from red turning to blue back to red again. Very, very unusual. And we have some other ones that are extremely unusual as well. Let's see. These are the Higgs fields, and that's coming from the Venturi at us. So these particles are, from here to here is raw energy. These little white sprits are nothing but raw white part of the electrons. Here they concuss and they start to create these fields around them. That's what the Higgs fields are. Now this was just unbelievable. Now, I believe I saw a reverse spinning particle that was a white particle. From that last picture, I'll show you again. And I believe that's what happened here. It interacted with a regular Higgs field, but was a reverse field. And now it's got like a half a field, I don't know, a half of it going this way and a half going that way. Very, 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 that's the only time I've ever seen it. But here's where it came from, I believe. I believe that's it right there. They're supposed to all come through like this. But that one, I think, is not spinning to the right. I think it's spinning to the left somehow. I don't know. lot to look at here. The blue ones just seem to be so fast that you really can't see much of a thing. But you can see they're going fast here and slowing down up here. Spinning to the right means the particle drifts to the left. Okay, my friends, I just want to give you a little background. I understand this stuff pretty well. I'm deep into chemistry and physics and quantum and all that, bonding order. This is long ago I did this. And, you know, these are Millikan's oil drop experiments. And this is a little cheat sheet, that's why it's sort of torn up, about all the different things, Schrodinger and Hund's rule, Heisenberg's uncertainty principle. I think we're going to be talking about that today, where it says you can't know both the energy and the position of an electron accurately. And the larger the accuracy in energy gives a smaller accuracy in position. It's just nonsense, really. Change in energy times change in position is a Planck's constant, more nonsense. Schrodinger, more. Pauli, more. Aufbau, more. It's de Broglie. They were all working on a theory that you had gigantic protons and tiny little electrons, and that's all there was. And believe me, trust me, I did this I went through everything that you can go through as far as understanding molecules and, you know, everything, the periodic table, and it is electron floods. Hydrogen is nothing more than 1841 electrons. That's what it is. There is nothing more than electrons, and they are dipoles. Electrons are not just negative. They're little tiny bar magnets. I show this over and over and over, which I will again. But let me just mention to you what this guy is going to be talking about. This is a royal institution. And this guy was with his 6-month-old niece, and he was amazed at her wanting to understand everything. And that's what happens when kids want to understand everything. But at a certain point, and he talks about at a certain point you just change. No, you don't. You don't change. They change you. They say, just listen to me, and if you repeat what I say, you're going to be smart. Don't worry about it. Nobody can understand it. And that is exactly what they say at Yale.
Niece, and I was just read this chapter again, and I was watching her bright-eyed and sort of amazed at everything around her, and I was thinking about this way her brain was working and her eyes were working, and at that age you're just absorbing everything. It's almost overwhelming, and there's this tide of information just zooming into this young brain, and it's absorbing. It just can't really remember anything because it's just processing all this stuff. And as you get older, that tide, I guess, begins to slow, and at a certain point, as you reach maturity, that tide starts to turn, and you're able to operate in a complex world and formulate ideas and complex thoughts because you have this ability to do what you're saying in terms of the brain feeding the eyes rather than the other way around.
All right, his point is your brain makes your eyes see things that really aren't there. And that's really what the whole point of the thing is. Right? And I think he's misunderstood it or whatever, because just like he said, let me go a little further and see if maybe I'm misunderstanding this.
And so there's this, I saw it for real with my niece in this amazing kind of sponge-like absorption at that age.
So let me just try to close saying that I guess my wish is that we can be like the 6-month-old girl a little bit even in later years, being an awe of what we see and being open to reabsorb it and change our mental.
Exactly. We need to be open and reabsorb it, and we need to go back to being 6 months old. Because once you get to a certain point, just he said it, but he didn't realize what he was saying. He's saying that you're locked in, and your eyes now are driven by your mind, and your mind has been programmed to say, that's impossible because my teacher said it's impossible. That can't happen because my teacher said that can't happen. I can't say that because I'll lose my job. Literally, that's the case.